Hi everyone, it's Mandi with Global Hemp Association. I just wanted to give a shout out to all of our sponsors. It's been incredible working with each of you. Without you, we wouldn't be able to complete the projects that we have and get our seeds in the ground for this year's fiber variety trials. So thank you for everything that you've contributed. For anybody else, if you're interested in getting involved and want to contribute or sponsor, please reach out. We can make it happen.
Hello, we're live. Oh, and I think that you're on mute. There you go. Perfect. Yes. Hello. Thank you so much for joining me. And thank you everybody else who's listening in. On LinkedIn today, it looks like LinkedIn, YouTube, and Twitch, we're streaming live too. This is recorded for those of you that may miss this or see it later. It is also streaming to multiple different podcast channels moving forward with Mandi Kerr, and then Global Hemp Association on all of the other social channels. So be sure you hit the little reminder. Let us know where you're chiming in from. We would love questions. This is a great topic, something that we don't talk about a whole lot. And outside of traditional decortication or processing, this is what would we consider this, Stefan? A secondary processing? Really a farm to product solution.
I wouldn't call it secondary. I would like to call it primary. It's just another way of doing something new with this great material, and maybe trying to also solve some issues that we have in the supply chain by going along with it.
Awesome. Okay, well, before I rattle on too much, I want to remind everybody, we go live Tuesday, Wednesday, and Thursday, 10 a.m. Mountain Time on LinkedIn, YouTube, Twitch, and Facebook. Like I said, on multiple other channels. Next week, we have 3 fabulous interviews with multiple people within the industry. Check out our social channels or Facebook posts, LinkedIn posts. I'm super active, but you'll be able to follow along. And then also, I'll share here in just a minute the link on our globalhempassociation.org website, where you'll be able to find all of the upcoming interviews, events, Q&As, live events, also a toolbox full of all types of data and resources for people within the industry or looking to use hemp within a material or an existing supply chain. So just want to give a quick reminder and say thank you very much for everything that everybody does. And without further ado, Stefan, you want to tell me, who are you? Where'd you come from? And how'd you get into this industry?
Well, first of all, thanks for the opportunity to talk a little bit with you. I really enjoy your. I didn't see all of your podcasts because there's so many by now that it really takes a long time. But I did see some. I really enjoyed them, and of course, hello to everybody out there who is interested in what maybe I can contribute to this whole story. My name, as you already mentioned, is Stefan Radlmayr. I'm German. Lived many years in Brazil. I always like to say that aside from the things we're doing in I'm a farmer in Brazil. Together with my wife, we're running a pretty big agricultural operation in Brazil still. But I came back to Germany 5 years ago, got invested into a paper factory, and started to look for alternative fibers at that time. Thought we should maybe also look into non-wood fibers for that. Started out with something called grass paper at the time. Great marketing success, technically speaking, not so much, because in the end, if you try to use natural fibers and you don't pulp them, if you don't process them, there's just not that much value in them. We all know that. And that's really what brought us 4 years ago, 3 years ago, to start looking for alternative pulping methods. In the follow-up, trying to find cheaper sources for the paper manufacture. And at the same time, of course, as soon as you start looking at this, there are so many environmental advantages if we could really use annual biomass in a good way. But at the same time, we really need to make sure that it's competitive, that it's technically feasible, that we're using processes that are producing homogeneous outcomes, et cetera, et cetera. So it was a very exciting and very, how can I say, it just made me see that there's so many opportunities out there, especially on the technical processing side, that it got me fascinated. So even though we stopped paper production some 5 years ago, I'm still in the field. We're running a startup in Stuttgart, close to in the southern part of Germany. And by now we're ready to tell everybody out there what we think everybody should be doing.
Oh, I can't hear you very good. For some reason, sound just got a little bit.
Are you back? Are we
I
there?
can hear you great now. Yeah, almost like when you leaned back a little bit, it was just
Okay,
perfect out of
fine.
view.
Not
Yeah,
not
you're
a
good.
problem. I'll stay here. So when I came back here, I really thought that this was just an intermezzo. But now we have been starting this company. So many exciting things have happened over the last few months that here we are. So happy to listen to your questions, to your interest, and tell a little bit about what we think we can do for the industry, and of course for this wonderful plant. Not just for this plant, actually, because we're multi-feedstock. I have to say that
Yeah.
you can use our process for many different biomasses, but of course we enjoy very much the hemp as a biomass because it offers so many different applications which are exciting.
Okay, so you mentioned something when we were talking about the annual biomass. Can you talk about a little bit, how does that play a role in the process? And also what does traditional pulping look like in the industry compared to what you're bringing forward as a solution?
Well, I think the first part, what got me fascinated, what I really liked when we started this first natural fiber idea in paper. If you look at annual biomass, regarding the big challenge that we have, the climate change, I mean, everybody here talks about that, but that's true. Annual plants, they just have a carbon loop of 1 year. You can use this plant, you can use it for materials, you can use it for energy production. I think we're going to get into that a little bit. And of course, whenever we use biomass, we are going to emit the carbon that is originally captured in this biomass. So in that sense, if you have a biomass that recaptures that carbon within a 1 year carbon loop, that's spectacular. And even better if we can then use this material and leave it, for example, in building materials and keep it really stored for a long, long time. That's even better. And that's really what got me fascinated regarding annual biomass compared to wood biomass, because of course our turnover, that carbon loop of 1 year, is the shortest we have compared to carbon loops with even tropical plantations of let's say 8 years, 10 years. And sometimes in continental Europe or even in the States, we might be talking about 50 to 100-year carbon loops, which is great. I mean, it's a carbon loop. We are recovering the carbon, even with wood pulp. But of course, 1 year plants could add a lot of speed to that carbon loop cycles. And that's very exciting.
Okay, I'm going to mark that as a note for later because I want to talk a little bit about traditional, for those that don't know, and I don't really understand, right? And I've said this a lot, is hemp has uncovered a lot of things I didn't know about the supply chain and how things are made, from textiles to paper products, food, animal feed, and things like that. So talk to me a little bit about traditional pulping and what,
I mean, usually the big part, if you really look at hemp, I mean, there's a big issue because, of course, you need to really do the retting. That's a typical part. We need the degumming part of that. The decortication is a very necessary step. And that, of course, depends a lot on your location. It depends on sun. It depends on the weather. There's an element of surprise here, or of, let's say, non-controllability, which makes it sometimes hard to really plan your agricultural operations, to really do it at the right point in time, to be sure that you have all the equipment necessary, that the weather really plays with you. And I think the great thing, what we can do now, and I need to say that we do this especially for shorter fibers. We might also get into that, longer and shorter fibers. But especially if we're thinking about applications where shorter fibers can work well, we give basically through our process the possibility to control this whole processing stage much, much better. And I think we'll get into the way we do that. But it's important that we basically take straw directly from the fields. There is nothing else required than a shredding process. Get it into a size that our machines can eat it well. And then from there on, all of these other natural processes that you would usually use, you can sort of bypass. And that, of course, gives you much, much more control over the process of value adds to this product, which we think is a good way to do that. And at the same time, you also need to realize that typically this kind of pulping methods, if you really go into pulping this material in the classical way, you always use lots of chemicals. There's many pulping processes for wood pulp as well as for non-wood pulp, where you basically use chemicals to really get to the parts that you really want to. That's great because you get at least a yield of X% of the kind of product you want. But you always produce lots of side streams of residuals. And very many times these residuals, the only thing you can really do is basically burn them because they're polluted with chemicals. And that is also something we really try to avoid, because the second big aspect to our business, I think, it's not just the 1-year carbon loop, but it's a so-called, what we call the soil fertility loop. We think that whatever we cannot use as a value-added product, we really need to give that back to the soil and to the fields. And of course, we need to give it back in as pure a form as possible. It cannot be polluted, because once you pollute it, it shouldn't go back to the soils. So those two aspects, I think, are important. And in that sense, we think that we can really contribute.
Yes. Okay. So supply chain, right? When we look at the supply chain from field, you're taking a crop, multiple crops. What are some of the other crops you're using, or biomass and the other biomass?
Well, basically, that's the nice thing also about our process. It's multi-feedstock. So yes, of course, we started developing this based on a plant that's called wheat straw. I think everybody knows that. And of course, that's also why I like hemp, because wheat straw and hemp, they are not just energy plants like often used. They also produce food. So we, first of all, always look at these plants and say it should be a cascading value proposition. And we shouldn't use fields just for whatever industrial applications we want. We should really use also the food opportunity this presents in itself. But we have done banana stems. We have done, I talked about hemp, straw. We have done all different kinds of straw: wheat straw, rice straw, barley straw. We have been able to process grape stems. We have processed multiple biomasses that I can't talk about because I'm under NDA.
Sure.
You might want to, if somebody is out there and wants to Google our technology, where it was used, there's some major players out there who are also using this process. But again, I think hemp offers an opportunity here in the sense of that it is also a food plant. It can be an animal food plant. It serves so many purposes, which is really nice compared to some of these other biomasses.
Well, and something that I'm really excited about is the organic process, or the process that allows us to, after extracting or after removing the fibers or pulping, it allows us to then extract the sugars and, look at some of these additional processes. Can you speak also to, like,
Yeah, well,
what does this
I mean,
do as far as
I think
value add to the supply chain and for the farmer?
I think it's important before we get into maybe those product streams. It's important to understand how we do this.
Yes,
Basically,
please.
we're using a technology that has been around for 100 years. We haven't invented this. It's called colloquially, everybody knows it as steam explosion. We call it rapid steam expansion because it doesn't sound as dangerous. But the process in itself, I'm sure that there's many people out there who know exactly what I'm talking about. But for those who don't, just imagine your pressure cooker in your kitchen, and you're cooking potatoes. What you're doing is you're adding temperature and pressure. And then we do something that you shouldn't do in your kitchen. We basically take the lid of the pot, and we have a rapid steam expansion. If you do this in your kitchen, the potato will be on the ceiling and all over, and they will also be fragmented, and that will be a solution or a final process of the steam explosion process. So what we get from the steam explosion, and we're doing this, also important to note, where we maybe differ here. We have done this in a small scale amount. We don't need a huge industrial plant. This is basically 3 oversized 40-foot containers, a typical plant of ours. You can do it with much less biomass. You don't need to have a 1 million ton processing plant to be competitive. You can keep it small. But at the end of this, we basically have a process here where we have cellulosic fibers in a soup, as we call it. And of course, we do this lid opening in a very safe and very controlled way. It's a continuous process. So you typically, in a plant like this, would feed 30 to 40 tons per day into the equipment. You typically, depending on the biomass you're using, for straw, it's about 50% of fiber yield. For hemp, it's actually a little bit more. It's about 60% to our current trials. But still, we have this cellulosic fiber together with all of the other even smaller organic matter, which is in the soup, which is water, and the rest of the organic matter. And now it gets really exciting because we not only have the fibers, but as we have been doing this completely chemical free at this stage, this of course serves like a perfect fermentation substrate. And that's where we are coming from for biogas production. Actually, my partners have developed this for over 10 years to actually make a biogas use of non-easily fermentable biomass more possible. And just in the last 3 years that we really discovered, wow, this is even better. We cannot just use the liquid soup for the biogas, but we even produce fibers as well, which of course is a higher value creation. And in the same way as we can use this liquid phase, we call it liquid 365 for biogas substrate, which is of course then a biological fermentation process. What we've discovered over the last year of intense R&D, we can also use this basically as a feedstock for second generation sugars and other stuff, which is again even more exciting because of course the product value is much higher for these kinds of applications than if we just compete with, I would say, recycled paper fibers. I mean, everybody knows that they're worth almost nothing. And if you just look at the paper fiber business, then you have to at least look at the virgin fiber paper business or the food contact kind of packaging business. That's where it gets a little bit interesting value-wise on the fibers. But of course, these second generation processes, let's say we're producing building blocks for PHA, for bioplastics, compostable. We can use it for barrier coatings, then for the paper makers. These kinds of things are so interesting because they really add value. And that is one thing we also think is very important. This value has to stay sort of not spread out over a whole chain, because if there's too many people involved, not just do you have supply chain logistical issues, But in the end, also the guy who's really planting the hemp or whatever other biomass he might be using with our equipment, he's basically also losing the opportunity to participate in the value creation, because of course, once you just sell your raw biomass or your raw fiber, you're making much less revenue than if you can really add a product that is in great demand, in huge demand at the time. And we think that is something, if you do this intelligently, it really brings value creation back to those people who should really be participating, which is the producers of the original biomass.
Absolutely. Okay, so tell me who ideal partners are or customers of yours. Who are you
Well,
looking
I mean, of course, this equipment, it's not just, this isn't just a tractor, okay?
Yeah.
Even sometimes I like to explain to people when I talk about straw, just consider us the continuation of the harvester, right? Because first you take out the corn, and or the seeds in the case of hemp, and then we process the stalks. But in the end, it is sort of it is an industrial process. So typically, we're looking not just as a small scale farmers. Either we have big farmers, or we have cooperatives, or of course we have grain processing facilities. Those kinds of guys who know how to deal a little bit with some sort of technology, because of course you have to look at this as an industrial equipment, and it needs maintenance, and it needs operators that can deal with that kind of operation. But typically, we really think here in Germany, for example, I give you an easy example. We have about 9,000 biogas installations running. And of those, at least 20 to 30% have the capacity to run this kind of plant, because they already have the know-how regarding the CHP equipment, stuff like that. And if you can deal with your CHP project, you can deal with our equipment. And that's really what we want, because we want to bring the value creation much more at the beginning of the chain, and not sort of keep it centralized away from these guys, and in installations which a typical farmer usually couldn't even pay for, because the original capex is just huge, and we're trying to bring that down.
Okay, so I'm asking because I'm very uneducated in this process. That product then that is sold after this process, is it sold in the soup format, or from
No.
is it separated, dried? What does that look like?
Yeah.
And talk to me about consistency of fiber size.
Okay.
Because that's a big sticking point that we keep hearing in industry.
Yes, well, not really in our sense, because of course we have a sorting. We after our steam explosion is over, basically, and this is in an expansion tank, because basically you explode and it goes into an expansion buffer tank. And from there, of course, we need to separate now fibers. Some of, depending on the quantity of lignin, we can separate the lignin. And then we have the soup, which can then go into further processing. Now, the fibers, typically, they don't just go out in whatever size. Of course, we have refining equipment right after the steam expansion. This is classical paper technology. There's nothing secretive about this. And then you, of course, have a sort of a sorting stage to make sure that your size, if it's too long, and if it wouldn't go into paper production, for example, that you mill it down even further. So we can really control the size basically in a wet, in its wet stadium, and we can sort of rerun through the refining system those fiber lengths which, for example, exceed a certain threshold that you would need. Now, very importantly, as I said, we're talking short fibers here, and that is, if you could say, it's a drawback, because we're not really getting into long fibers, let's say with 20-30 millimeters. We're around 10 millimeters. That's sort of the max. And of course, this is for many applications very interesting, be it composites, be it certain textile applications, even in the beginning. And of course, we can mill it down for paper and paper packaging. So for these kinds of applications, these fiber lengths work really well. If, of course, you want to go into the typical textile applications, spinning, etc., you need much longer fibers. And this is not something where we aim at, because I think there is existing processes out there. But we feel that it's very important to give to consider that those longer fibers are a small fraction of what we have in these plants, right? So we think it's important to give a very industrial application for the mass of the product, and really consider that, especially if we break this down, then in a continuous biological process, even further onto a molecular level, then you can also rebuild this, for example, into endless filaments, et cetera, et cetera. There's really interesting processes out there to then valorize what we produce.
Yes, absolutely. Well, and there's some people now that are doing some crazy, like the material science space of being able to manipulate the fibers and make them, like you said, continuous from the cellulose. It's pretty amazing. I love it. Okay, so there's a quick question. I know we went over it a little bit, but George is wondering, Georgia Pacific closed a big plant using timber pulp and pollution emissions caused city to place way too many restrictions. How does hemp differ?
Well, that's exactly the point. I mean, if you look at Georgia Pacific and what they're doing, this is a typical chemical pulping plant. I don't know which one specifically we're talking about here, but it's a chemical plant. It has lots of issues. First of all, of course, with residual waste, it has emissions from these residual waste. You have big emissions. You need wastewater treatment because you're losing lots of water to do all of this processing. Typically, if you look at a wood lumber pulping plant, they will use between 10 to 20,000 liters per water. That's a modern plant per ton of pulp, dry pulp we're talking here about.
Yeah.
And older plants might be even using 100,000 liters per ton of pulp. I mean, look at those numbers. It's crazy. It's 1 to 100. And even a modern plant will have 1 to 6, 1 to 10, even though they're recovering lots of the water. So this is an issue. If you keep it like we do it, chemical-free and farm level, you're resolving many of these issues. You will, first of all, I mean, it starts with a simple fact. If you're out on a farm or in an agricultural operation, you might have cattle. You already have anyway this process. But our process is basically really, if we're not using certain materials which bring their own let's call it stink with it. If you're using straw or hemp or whatever in its dry form, there is almost no odorous emission at all from this process. And then again, secondly, you have none of the chemical residuals that you need to take care of. So, and the third thing, of course, is the whole issue is if you're on a farm level, you need to perform to certain agricultural standards. You cannot go in an industrial huge emissions situation.
Okay, so this kind of goes back, and I know we touched on it in the beginning. We've even touched on it a little bit, but really understanding this 100% valuation of the 1-year cycle of carbon, right? From fibers, cellulose, lignin, biopolymer, feedstock. Can you talk a little bit about, what does that look like from fiber, from farm back to farm on that waste? And how are some of the partners that you're working with really utilizing this to improve supply chain, increase, decrease carbon footprint, reduce emissions, so forth?
Well, I think first of all, again, the important part is that the size that we're using, this is almost the only way you can have a capex that you can sort of accept as a smaller operator in the market, right? You don't need to be a huge industrial conglomeration like many of these wood pulp producers necessarily are because of the high need for capex. Our capex is sort of adequate to what we're trying to do, and it's modular, so you can build up step by step. You don't need to invest in a huge plant at the very beginning. You can do this step by step. And secondly, again, what comes out of this process in our case, for example, paper fiber, we usually do this, we process around 30% dry, so the material is wetted to this point. And it comes out at the end of the process, typically in a agricultural baling operation. So if you know a typical bale, that's the way our fiber comes out of this process. And then, of course, if we're looking at biological processing, then there's all different kinds of ways to do this. But again, it's a typical fermentation process, which for agricultural operators, especially if they're running a biogas plant, that is something they absolutely know and control already today. So they already have the background, the technical background to be able to use that.
So your product, the fiber, after it runs through the steam.
Through the steam explosion, the refining, the separation, the refining, and then we bring it up to this 50% dry. Then it's basically baled and it's ready to ship, and it can go straight into paper or fiber molding. I like especially fiber molding operations. Why is that? It's not bleached. That's very important. I have to say that. We can bleach it. But as soon as you bleach it, what are we talking about? We're talking chemistry, right? We're talking chemicals. And to us, it doesn't really make sense if we're saying we have a very environmental process. Why would I want to get this brownish fibers? And it is really brownish in different colors for different feedstocks. Can go from dark brown to light brown. Hemp is actually a very nice sort of reddish color. I like it a lot, but it's more, I think that's a personal question of what you like or not like. But anyway, these kinds of products can then go, as I said, directly into paper production. But fiber molding is even more interesting because let's be realistic. We have these small plants. It is small plants, right? We're talking 10,000 tons of biomass, and then we produce, let's say, 5,000 to 6,000 tons in one module. We can add to that. In Ukraine, we actually have an installation where 3 of those modules work together, and that would be around 15,000 tons of fiber. I don't have to tell you that, of course, all my sympathy goes out to the Ukrainians right now, but I'm personally mad that
per year.
Sorry.
Per year, 15,000 tons of fiber.
Yes, 15,000 tons of fiber per year. But what I want to say is, of course, if you're looking at this from a paper factory perspective, it's like, oh, come on, 15,000 tons per year, and then we need 3 operations, etc. Sometimes the scale of this doesn't work together with the scale that they need. Now, for fiber forming, typically these installations are smaller. We're talking 5 to 10 to 15,000 tons in one location. They, of course, also have a higher value add than the paper business typically has. So we really think that in the first stage, it makes much more sense to think about these applications with our fibers. And of course, also thinking about composite industries, which can really work great stuff with our fibers. I mean, one example I can give to you, which I find is spectacular coming out of our R&D right now, is a vegan leather, which is nothing new. Again, many people do this, but the nice thing about our process is that all the basic processing to get to the fiber is chemical free. So it has a great look. Not just feeling and looking at the material, but also if you're looking at LCAs, life cycle analysis, etc.
Yes. Okay, so talk to me fiber forming. Give me some examples of what that is compared to a composite.
Food packaging. You go to McDonald's and you receive and you want a soup. You're not going to get it in paper packaging, right? You will have before that, we have one-time use plastics, and now you can use basically these kinds of materials for this kind of packaging applications. Of course, you also have many industrial applications where you need to make sure that your equipment is stored exactly in a certain way, and then you form the packaging material exactly according to the needs of the packaging object. This is there's all different kind of value creation there also. Of course, the top level would be food contact packaging, and it also goes down to very industrial, automotive sector or others, where they also need to protect certain components, and you can use these materials very well. I think an interesting aspect of this is as well, if you go into industrial isolation materials, etc., but you always need to make sure that if we look at annual biomass, let's not go for the low-hanging, low industrialized fruit. Let's go for the high value creation, because only with high value creation we can pay the capex the OPEX, and we can give the farmers who really produce the material a good share of this value creation.
Well, the reason to grow it, right? This is really what our industry needs, is that high value product that's going to give farmers a reason to buy space away from any of these other commodities that are record high prices right now.
But that is exactly also what I think is important if you think about this cascading thought. I think it's very important that you don't just grow this for, let's say, for cannabis. Let's even take cannabis. If you look for the medicinal application, there's always biomass involved that usually today doesn't really get a higher value creation from it. But combined with the original target of your production, and then you can still use this biomass in an intelligent way for higher value applications, that really makes a difference in your overall revenue. And then you can really start to look at this, especially also hemp, maybe in a different way than you would look today if you just depend on one revenue stream.
Okay, so I want to understand, because this comes up a lot, and I don't know if those that are listening, if you guys have questions, please chime in. Feel free to ask. There's lots of information that's been shared. George, thank you very much for chiming in with questions. And John, as always, thank you so much for saying hi. Of course, my dog's going to start barking. Consistency, of that fiber length, and for materials that it's going into, where are and how are you guys really managing that? I say all the time, not only micron size, but length, and, how it's sorted, and, how does that impact these industries you're going into?
Well, as I said, because we have, it is an industrial plant. So we have certain systems in there that we can add after the steam explosion process, which in itself is, of course, not producing very similar, very equal pieces. It's a range of fiber lengths. But then, as I say, in the continuous process, we can sort of filter out certain segments. And the nice thing is, whatever we filter out or whatever we do not use for a certain demand on the final side, we can then either bring back into the liquid phase and use that in whatever higher value application we want to use it there. You're not losing it. And that's a big issue, because typically if you process annual biomasses, there's a lot of loss. You will have, if you look at flax, sometimes you have a ton of that material, and in the end you will get 5 to 7% yield of the total material. Okay. And the rest sort of, there's no value application for it. Right. Now, if you go through our process, you might not get those 5% highest value kind of applications, but you will get 100% value creation out of what's there. And we can, because it's an industrial process, take some of those steps that you usually would maybe not be doing on a farm level. And that helps a lot, because, of course, as soon as you get to what you're talking about, more uniform lengths, especially for paper making, that can be done on site. And then you really deliver something that the paper factory can use directly. Now, for fiber forming, that's less of an issue, because if you really work in a wet laid process here, or also for non-wovens, fiber length is important, but it doesn't need to be as uniform as you would need it for the paper production. So but it always depends on who is in your area, who is going to be your best customer for that. And then, of course, in the end, even though that's still a little bit in the future, but as I said, if we really want to break this question about how uniform are we, what kind of lengths can we produce, then we really need to break this cellulose down almost to a molecular level, and then reform it into very, as I said, filaments, for example, is one good example of that, where you can put endless filaments, and then, of course, you have exactly the same fiber, you have exactly the same properties over all of your material. But the thing is, we think we can do this in the future, sort of as a follow-up process to our very own steam fiber plants. We call them steam fiber plants, by the way, our modules. And if we can add, for example, these kind of processes at the end of the breakdown of the original lignocellulosic material, then, of course, you have a whole different value creation on a farm level. And that's really what we're what we're most interested in right now, because of course the higher the value creation is, the more easy it is also to suggest a certain capex, because of course this requires an investment always.
Absolutely. Okay, so Darwin has some great questions, and thanks very much for joining in, Darwin. He's curious about how you measure the length of fiber and what instruments and test methods do you use?
Well, basically, as I said, we're coming out of a paper factory. So we, of course, use the typical paper industry procedures and instruments. And you always have that as well. There are sieving methods, there are sieving equipment. This is nothing new for paper makers. They have this. So that's what we're using as well. And that's what we're based on that experience. That's how we developed also our system in this regard.
Yeah. Okay. And then, of course, he does great work with ASTM. Wondering if you're interested in helping ASTM standards, international developed standards for these skids.
I always think that's another issue that we should all be working on. Yes, I think we should talk about this. How can we really define good parameters which are achievable? Because there's also no sense to not be open about this and transparent. A biomass like that, if it's not broken down chemically until the very end, it needs different standards than a wood pulp in one of these most modern plants can offer. So we need to make sure that people understand that. And I mean, I give you a good example. When people ask me, well, can you do graphical paper with this stuff? I say, why would you even want to think about it? I mean, it's brown or brownish. It's not as nice as a super processed white paper fiber. So we really need to look at the applications. But if we're talking about packaging, for example, usually that is not an issue at all. We can have different surfaces. We can work also with other kind of parameters. So yes, that's a good suggestion, and I think we should all think about that at some point in time soon.
Absolutely. How do people get in touch with you if people want to have questions about technology or ASTM standards work you're doing? How do people reach out?
Well, of course, I'm on LinkedIn. Fibers365 is on LinkedIn. You can also find me on LinkedIn under my name. It shows up on site here, Stefan Radlmayr. Of course, we also have a website, Fibers365.com. You just send an email to info@fibers365.com, and we will be very happy to talk to you and help you with your questions and suggestions.
Awesome. I'm going to share some of that contact info so that it's on here. Anything else? Where do you see? First, let me back up really quick. How many countries are you guys operating in? How many locations?
Well, right now, basically, our business model is not. I don't want to see Fibers365 as the biggest supplier of non-wood fibers all over the world. That's really not our goal, because I really think we need to have this really spread out. We need to have lots of operators who can take advantage of this technology. So our basic business model is we help with the technology, and then we license the process and help also with the selling of the material, and of course establishing network rates, etc. That's our idea how to do this in the future. Right now, of course, as I said, we're based in Germany, so we concentrate a little bit on Europe. We have some partners in North America that are helping us to also look at this. Shout out to some of those people out there, Benemat, Yitzhak, Restock, some other peoples that I'm not allowed to share their names. But anyway, there's people out there looking very closely at our products and helping us to develop ideas also for North America. And I think in the end, we need to work together. We need to have more intelligent processing solutions for annual residual waste. I mean, if we just chop it short and use it for the most low-tech applications imaginable, this is never going to be a good value chain. And then, of course, happens what you just said about either we're losing value creation out of side streams from food crops, or we even don't give any incentive to people to just produce more biomass that could be used in such a environmentally good way, looking at climate change issues and carbon capture, etc. I mean, I'm always saying, when I hear a lot about carbon capture technologies and stuff like that, and I say we have the carbon capture technology. It's called nature. It's
Yes.
called a 1-year cycle
Yes.
of annual biomass. Best capture ever. We don't need to worry about how efficient are we there. We just need to make sure then that carbon that we captured through this great process called photosynthesis, how can we then really store that in long-term products, and how can we make this available for as many industrial uses and consumer uses as imagined? Why would we want to do great technical stuff? Yes, it's great if we can do it, but I'm looking forward to that. But I really doubt that we should compete with billions of tons of carbon captured every year through nature. Let's just make sure we then process in a way that we release less of this carbon, and that we make products where we store as much of this carbon as possible.
How often and relevant is the carbon discussion as you're discussing this new technology?
I think it's very important. I mean, I'm not telling any secrets here. Of course, any big, all the big, let's take consumer goods producers, etc. They all have a look, of course. Everybody wants to be carbon neutral at some point. But I really have to tell you that in the end, I think as soon as it gets to money, I still feel that it's not worth what it should be worth. The carbon capture or the carbon release algorithm here is still not in a way that you would say, okay, people are willing to pay for these environmental benefits. They might pay a little bit, but they're not going to give you a huge advantage. So in the end, it's really our responsibility to be competitive in these areas where we can be competitive. As I said, in our case, I cannot compete with recycled paper pulp. That would be just ridiculous to say that there's a way to get there. I don't think so. Now, can we compete maybe with virgin wood pulp? Yes, we're already there. We can do that. And we can definitely, I think, compete on some of those high-end applications that we also talked about, because the basic process is, because of its no need for chemicals, because of its energy efficiency, we can start out with you could call it a pre-treatment that allows many applications at a better price point than many higher-end applications would be.
Okay, so I like this. My next question was going to be about the adoption of these of these consumer goods companies using a different product than something they're used to. Because it's meeting some of those specs, is it pretty easy to transition from, say, a wood pulp to a hemp pulp or another biomass?
Yes, but you're touching on a very important point. I mean, let's talk paper machines, okay?
Yeah.
Paper machines are big machines. They're running at huge speeds. We have to be honest. As soon as you start bringing in lower quality pulps, you will have efficiency loss in these machines. And we really need to consider these kinds of things. So that's why I'm also saying, let's go for the applications where we can keep or maintain the same efficiency without really trying to compete on this. At the other hand and I think we need to be careful with this as well, I want to make sure that we don't allow greenwashing by using just partially certain mixes and blends and saying, oh, this is green, and then in the end you look at it and there's maybe only 5% of that material in there. So I think we also need to be careful. Let's not mix this up. Let's really go maybe for 100% applications, or let's say at least majority hemp-based or annual biomass-based applications, instead of trying to enter into markets where we sort of give them a fig leaf and at the same time not really contributing.
Not making any change. Yeah,
Yes,
we're not making
exactly.
any change. That's another thing that really blows my mind, is you really don't have to have very much hemp in a hemp plastic bottle to label it hemp plastic.
And that's we were talking about standards. I always feel I could scream if I leave, oh, this is hemp paper or whatever.
Yeah.
And then in the end I find out, oh, you
10%.
put in 90% wood pulp and you're using just 10%. Let's be honest, that is not there's a very marketing situation here that I think we need to be careful of. But
Yeah.
as I said, I mean, we've gotten great support from some of the biggest in Germany. We have a very huge a retailer that helped us a lot to develop this, because they're really wanting. There's many people out there on these in these big companies who want to make a change, and we need to offer them products that they can use.
Yes, well, I love it. How can we support you best? You know, what can the association do? What can viewers do? Or maybe even people that aren't in the industry but may have connections outside of industry?
Well, I think there's many aspects to this. First of all, we always like to talk whoever is active in the field, and we're always willing to listen to ideas and help develop projects. Of course, we're a small company. We always need to sort of look at where we can dedicate, but I really think what everybody can do is sort of spread the message, and I think you're giving a great example of what you're doing here. Helping people to look at different technologies. I always say that there's so much space for all of us in this annual biomass processing ideas. I think the best we can do is just really share the best ideas, and really also try to look outside. I mean, what is my neighbor doing? What is my competitor doing? And if it's more intelligent, I have to tell you, let's all follow him, because in the end, we need to be competitive to really offer this product, this biomass product, in a competitive way. Because if we cannot offer it in a competitive way, it's not going to take off. We're not going to change anything. People will
paying attention to that value add component is so important because can the industry scale on hempcrete and animal bedding?
Well, if you ask me, no. Yes,
Right?
it's great markets, and I'm glad we are doing that. I think environmentally wise, this is perfect. If we can have this stored carbon captured, this captured carbon stored in buildings, yes, that's a great idea. But let's try to use it for as much value add as we can, because then we can really, create the incentive to have much more hemp, to have much more value, and to be in much more products and be available. And there's also one other thing that I would like to maybe point out. One project I'm involved in, which I think is spectacular, is actually using hemp for peatlands, for the recultivation, the re-wetting of peatlands. People who know a little bit about carbon and carbon emissions, they know that especially peatlands are very, very important to maintain where we are right now. For the last 50 years, we spent a lot of time trying to get them wet and trying to get them agriculturally productive. And I would love to follow up with people also in North America, maybe some of those ideas that we're following here with something called paludicultures, with fibers, and hemp could be one of them, that grows in re-wetted peatlands, which then have a huge effect to really block carbon emissions from these soils, and at the same time maybe give a good value creation to the people taking care of this. So if you have a good piece of peatland around you, talk to us. We have some ideas.
Yeah, I would love to dive into this more. In fact, coming up in the next month or two, we have a pretty good farm series that I would love to invite you to participate in, either as a guest speaker for Q&A, but really get the discussion going with agronomists and people that are doing exactly that. Maybe not on peatlands. Like I said, it's not something I had heard, but holler out. If anybody else out there knows anybody, please reach out. Okay, well, thank you so much for joining today. Thank you, everybody else. Darwin, for chiming in. What's your email again? Did you say info@Fibers365?
Info@Fibers365, or just use my first letters of my name, SR@Fibers365. If you have a question, I'm happy to try to answer.
.com?
Yes, Fibers365.com. Sorry. Yes.
Perfect. No, you're just fine. Absolutely. So thank you very, very much again for joining. If there's anything that I can do, please don't hesitate to reach out. I'd love to support you. I'm very interested in your technology. I would love to learn more about it and understand it. And so let's stay connected. Again, we have 3 other interviews next week talking about decortication, equipment design, layout, things like that. And then we actually are going to be interviewing and talking to the team on GOTS. counts, the standards group, and so around textiles. And so I think it would be a great conversation, Darwin. I'd love to have you involved there and just kind of dive into what they're doing and where hemp plays a role in some of their work as well. But don't hesitate to reach out, you guys, if you need anything. Mandi at globalhempassociation.org, or you can find any of our contact info on globalhempassociation.org. And if you're going to be at NOCO, I'd love to see you. We are going to be presenting our fiber trial data from this year's 2022. I guess not this year now, last year's 2022 fiber trials, where we planted in 10 states, 10 different varieties, just kind of showing what's worked, what didn't, what some of our results were, some of the things we learned where we didn't get the best results. And so I would love to share. Anyways, thank you guys very much. Stefan, thank you again very much for joining, and we'll see you next time.
Thank you. Thank you all. Bye-bye.
Thank you guys. See you later.
Hi everyone, it's Mandi with Global Hemp Association. I just wanted to give a shout out to all of our sponsors. It's been incredible working with each of you. Without you, we wouldn't be able to complete the projects that we have and get our seeds in the ground for this year's fiber variety trials. So thank you for everything that you've contributed. For anybody else, if you're interested in getting involved and want to contribute or sponsor, please reach out. We can make it happen.